Hi, everyone. I'm Jim Hounshell, and welcome back to the Old Radio Revival. Before we dive into today's restoration, I want to talk about one of the most fundamental yet overlooked principles in electronics: grounding. An antique radio must be properly grounded to work safely and effectively. Without a solid ground connection, you risk dangerous electrical shocks, damaging short circuits, excessive hum, and in worst cases, even fire. The ground wire provides a safe path for excess energy, stabilizing the circuit and protecting both the device and the user. Our lives desperately need grounding too. In a world that's constantly shifting, where values change with the latest trend and opinions sway like reeds in the wind, it's easy to feel confused and spiritually at risk. We can try to ground ourselves in fleeting pleasures, temporary success, or the approval of others, but these are like faulty ground wires. They offer no real stability or protection. The Bible tells us that our true grounding is found not in the shifting values of the world, but in Christ. He is the solid, unchanging foundation that anchors our souls amidst life's storms. Hebrews 6:19 beautifully describes this. We have this hope as an anchor for the soul, firm and secure. Just as an anchor holds a ship steady in turbulent waters, Christ provides unshakable stability for our spiritual lives. Obeying the gospel grounds you in what truly lasts. It's about connecting your entire being to Jesus Christ, who is the same yesterday, today, and forever. When you surrender to Him, you establish a spiritual connection that provides safety from sin's dangers, stability against life's uncertainties, and clarity from spiritual interference. So, as we ensure our antique radios have a proper, safe, and effective ground connection, consider the grounding in your own life. Are you truly anchored in Christ, or are you drifting, susceptible to the shocks and shorts of a chaotic world? Let Him be your firm and secure anchor. Now let's head over to the workbench. I got those speaker wires connected back to where they're supposed to be. I've extended the antenna wire out and put a new ground wire on. And I went ahead and reconnected the wires to the light bulb socket. Now we're ready to put the power cord back on. So let's do that. Put it back through here. As I recall, the straight one here was my positive or my hot lead. It has writing on it, so that's my hot. And then this one goes back over here. And I want to put a knot in this so that it doesn't get pulled out. So I need my knot right about here. So let's see if I can do that. That'll work. Right in there. here. We're good enough. All right. Got that in place. I nearly forgot that before I connect the hot side to the switch, I want to run this through a fuse. Because if there's a short in the radio and it starts drawing too many amps, that could burn up important components within the radio. For example, the transformer. We don't want to do that. So if we run it through a fuse, if there's a short and it starts drawing too many amps, it'll blow that fuse and it'll protect the radio. So I want to run it through a fuse, and on the other side of that fuse, I want to put a resistor to cut down on the amount of voltage that is going into the radio. Depending on what day it is, my house voltage runs around 123 volts. If we look at the schematic, we see that this radio was designed to run off 115 volts. So I want to get it down closer to that 115 volts. So the setup I'm going to have is the hot side will be on a fuse. On the other side of that fuse will be a resistor, and then that resistor will connect to the switch. So that's what the setup will look like. So what size resistor do we need? Well, in order to determine that, we use Ohm's law. Ohm's law says that resistance equals voltage divided by current. So we need to figure out what our voltage is and our current draw. Well, to figure out the voltage, we take the 123 volts minus the 115 volts that we want, and that brings us to 8 volts. So it's a drop of 8 volts. That's what we need to use in our formula. So now we know the voltage. We just need to determine what the current draw is. In order to do that, we use another formula. It's called a power formula. And it says current equals power divided by voltage. So again, looking at the schematic, we see that this not only operates on 115 volts, but it draws about 46 watts. So those are the two numbers that we'll use in this formula. So we take 46 watts and divide it by 115 volts, and that gives us about 0.4 amperes. So now we have our two numbers for the formula. Resistance equals voltage divided by current. So 8 divided by 0.4 equals 20 ohms. So we need about a 20 ohm resistor in order to bring that down closer to the 115 volts. Well, while we're at it, what size fuse do we need? Well, a good rule of thumb is to go about 150 to 200% above the operating current. Well, we know our operating current is 0.4 amperes. And if we take that times 1.5, which is 150%, that equals 0.6 or 600 milliamperes. If we do 200%, that's 0.8. So I happen to have a 0.6 or a 600 milliampere fuse, slow burn fuse. That's what we'll use. And we want to use a slow burn because there will be a spike, perhaps of over 0.6 for a few seconds. Well, we don't want it tripping that or blowing that fuse every time we turn the radio on. Once the radio's on for a few seconds, it starts settling down and it'll go below that 0.6 and we'll be fine. So that's why we want a slow burn fuse. On the resistor, I don't have a 20 ohm resistor, but I have a 15 ohm. It's a 25 watt. What size wattage do we need, I wonder? Well, there's a formula for that. Let's take a look. In order to determine how much power a resistor will dissipate, and it dissipates it into heat, you use the formula power equals current squared times resistance. So in our case, we know that the current is 0.4 and the resistance is 20. So 0.4 squared, or 4.4 times 0.4, is 0.16. And then you multiply that by 20 and you get 3.2. So you need 3.2 watts, 3.2 watt resistor. But to be on the safe side, go up to about 10 watts. And in my case, I don't have a 10 watt, I only have a 25 watt, 15 ohm. So we're going to stick that in there and see. I mean, the 25 watt, no problem. 15 ohm, let's see how close it gets it to our target of 115 volts. It doesn't have to be exactly 115, but I do want it lower than the 123 house voltage. So let's stick it in series here and see what happens. Okay, so I've got the power coming in, the hot side of the cord connected to the yellow lead here. The other end of the yellow lead is connected to the resistor. Then I have a green lead on the other side of that resistor, which goes and connects to the switch. So let's take our multimeter here and see how many volts are going into that switch. So just under 117. So that's good. I can live with that. So that's what we're going to go with. Even at 25 watts, this thing was getting a little bit warm, not hot, but you could feel the heat. So I think 25 watts is going to be good. Plus, I'm going to mount it against this chassis on the inside. I'm just going to put it on the side of the chassis. And then the chassis can also absorb a lot of that heat. So I don't think that's going to be a problem at all. So let's get started. I'll put the fuse on here first, and then we'll put the resistor on. This is the little fuse holder that I'll be using. I'm going to set it right against the chassis like that. But these prongs here on the end where the wires will connect are going to be just a little bit closer to that metal chassis than I feel comfortable with. So what I've done is I've cut out a piece of heat shrink tubing to size, put a hole in it to match the hole here in the middle. But I'm going to put that under it, put that between the chassis and my fuse holder, so that if those wires do accidentally get too close there, they'll be against the rubber and not against the chassis. I think the first thing I'll do is go ahead and attach this wire to the fuse holder. I think it'll just be easier to do before I actually get this down on there. So that's the first thing I'll do. All right, I've got the wire down through the hole. Now I just want to bend it this direction. Then I'll solder that on there. And yeah, that'll stay away from the chassis, it looks like. So next we'll solder that down. I've got those two on there. I'm going to take a small piece of wire and connect this side of the fuse to the resistor, and then a longer piece of wire to connect this side of the resistor then to the switch. There we have it, 116 volts. That's great. Now the radio is protected with a fuse and operating near the voltage it was designed for. Join me next time when I will fix the damaged speaker and I'll put the labels back in place. I hope you're enjoying the series, and I hope you'll subscribe to the channel. Thanks for watching, and I'll see you in the next one.